Alright, so I have begun recording there, so wonderful. The first thing that I want to say is I apologize that this was more of a struggle than I planned on it being. I felt that I had pretty aptly explained it for all of my classes, but maybe not so much, so I apologize for that, and so that's why I want to do this. And I apologize, like I said, for the late notice like I said in my email. It was kind of I'd gotten so many emails throughout the day as I was trying to do grades that it was honestly kind of getting on my nerves a little bit. Not saying that I'm mad that you were asking questions for clarification, but my phone constantly vibrating was starting to piss me off. So I just said, screw it, I'm done getting emails. I'll just send out, we'll do this and we'll get it over with. Yeah, so that's that. With that being said here, hold on, I need to change up my setup here. I forget how I like to do this. This needs to go there, that needs to be on that monitor, this needs to be on this monitor. Lovely, lovely. Sorry, I forget my setup because I haven't run it in a while. I think that's the one that I want. Yes, okay, cool. Alright, so we can go ahead and get rolling here. The first thing I'm going to say is I really hope that you were looking at the how to make a good data table Google Doc that I had shared. That Google Doc I feel like is probably going to answer a lot of questions that people had just about the structure of the table / tables that I'm looking for. So if that was more your question, I hope you were able to look at that and it was helpful for you. If not, that's probably why you're here. So I don't blame you. Alrighty, so we can go ahead and get going. I'm going to do this. I'm not going to share my screen. I'm only going to change just which quote camera I'm using. So that might mean that you need to pin me rather than expect me to share my screen or something like that. So if you can't see, if you can't read what these are saying, I ask you to please pin my camera so that I am nice and big for you and it's not just small. You can actually see it. Wonderful. So here we are. Here's our deal. Here's our lab. Again, the words are still sloppy. The words might get a little sloppy here. I will try my best to kind of point out the things I'm looking at, such as if I'm talking about something, I might highlight it. We'll see how it goes. Also, sometimes my OBS likes to just break, and so it might like glitch out. That's just OBS being crappy. Shout out open source programs. So the first thing I want to point out is our research question. Because if we were to go take a look at something like the data table, the data tables that I gave you to work with aren't perfect. They're not the best. I get that. I get they're not good. There are pieces here, there's some information here that's probably missing for you. You would probably look at these and say, hey, wait a second, I don't know what the heck I'm looking at here. Specifically, what these bolded numbers mean. You're probably looking at these going, I don't really know what these bolded numbers mean. I don't get it. What are these? Well, if we take a look at our research question, we're looking at how temperature affects the time it takes for Alka-Seltzer tablets to diffuse. So here's our independent variable, here's our dependent variable, time it takes to diffuse, but notice in a good research question that we have the units of measurement for both variables. So the first thing I'm going to say is that these bolded numbers here, while aren't given a unit in the table, are given a unit based off of just what the research question says and how it's written. I know I say that all the raw data here is in seconds, and even if I didn't say that, you could go back here and say, oh, it's in seconds, time in seconds, cool. So that's the first thing I'm going to say right off the bat. If that's what you're missing, cool, love that. The next thing I'll say is we're going to skip this stuff because this is more the stuff that we're not focusing on. This is more Criterion B stuff. the thing that we're going to focus on is everything down here. More so specifically this part, because part 5 is more your own stuff. Part 3 and 4 is what we can do to get to part 5, and that's going to be the stuff that we care about. I'm going to say this one more time, because I said this for all 4 of my classes. This data document, the one that we see here, has 3 sheets to it. Class 1, Class 2, Class 3. All of this data is working to answer the same research question. This research question. It is all working to answer this research question. Which means this can all be compiled, all of this data from Class 1 and Class 2 and Class 3, into a single table. I don't mean, copy this, copy sheet 2 or Class 3 and put it to Class 2 and copy Class 2s and Classes 2 and 3 and put it to Class 1. I mean, we can make, if we come to our Google Doc, a single table that looks like this from this data. Except instead of having 1, 2, 3 manipulations of our independent variable, we have 1, 2, 3, 4, 5. And instead of having 1, 2, 3, 4, 5 trials, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 trials. That's fine. That's good. In what we've been working with, between catalase, between paper airplanes, we've been staying in a smaller trial range, like 5 or so. That's just nature of, we have class time that we got to get through. But you're given 12 trials worth of data. Use all of the data. You're given 12 trials for all of the manipulations of temperature here. So let's use all 12. So we want to make a single table that looks something like this, involving all 12 trials, all 12 pieces of data here. And to kind of give you a little bit of a refresher, we're going to jump back to the paper airplane stuff. So back in the paper airplane stuff, I gave a quick little workshop as to how to best make a graph in Sheets. So we're gonna, we're looking at that here. That's what these are. That's what these are representing here. Now the first thing I'm going to say is between this graph, the super colorful graph, and the blue graph here, which one of these is easier to read? And you can actually tell me. You can put it in the chat, you can say it out loud, which of these is easier for you to read? If we're trying to determine how paper airplane design affects the overall flight distance, or the average flight distance, which of these two is easier to read? The super colorful and rainbow looking one, or the super simple blue one? So I got a couple of people saying blue, a couple of people saying one. For me, I like the simple stuff. I think this is a lot easier to read than this. If I were to try and make an analysis, make a conclusion, draw information out of the numbers, I've got a lot going on here that I can't really pick out very well. Now granted, I've labeled this graph pretty well. I've got, all of the blue bars are the first trial for each of the designs. The red is the second, yellow is the third, and the green is the average here. So I've got the information here that I care about, but there's a lot more going on that's just visually loud and kind of getting in the way, and that will end up affecting your brain a little bit as you're trying to make inferences, because you've got so many other signals coming into your brain that your eyes are reading. So if you were to, oh, I've got people sitting in the waiting room. I hope they weren't waiting too long. If you're looking at a graph like this and you're trying to make some sort of conclusion here, this might end up being more difficult than if you were to just do something like this. This graph that I'm looking at here is merely all of the green bars from this other graph, just by themselves. That's it. The data that I graphed in here right? This is the data that I graphed in my super colorful rainbow graph. This includes all of the raw data as well as the average data, the processed data. Whereas in this graph, all I have is just my average. It's just my processed data. By only graphing the processed data here, the stuff that you do the numbers with, it's going to make your life a little bit easier if you're trying to make claims and make conclusions and inferences based off of trends that we see in graphs. Now, granted, sometimes we only have raw data, and that's fine too. Something like the data nugget with the caterpillars was only raw data, which actually it wasn't. It was actually processed data. Now that I think about it, there was just 24 different data points. Right? Imagine that data nugget with a caterpillar, but each one of those 24 species, you also saw all 5 of the plants, all 5 of the trials that they had for it. That would be insane. Imagine trying to graph that one by hand. So the first thing I would recommend is if you're going to be making a graph, I highly encourage you to make a graph from your data that is processed. I highly encourage you to graph your processed data, the things that you're doing math to be able to better make conclusions from. Now, with that being said, I would strongly encourage you to tabulate all of your data. Notice that the data that I've got in this table here is all of the data that I have here. It includes all of my raw data as well as my processed data. I want my reader to know what are all the things that I did. What are all the pieces of information that I had to work with. I want my reader to know that. I want to be as transparent as possible. But if I were to now take this and I'd say, hey, I'm going to show you the thing that actually really matters here. And I forget how, I think you can copy chart here. If you select the graph and you use the little triple dot, the hamburger button, you can copy the chart. You can go to where you want it to be, and we can paste it. And you can also paste this to link to the spreadsheet, which means that as you update the data here, not only will this graph update, but so will this graph. Right, so let's say instead of having 106, I actually meant 601. Notice now we've changed here, and if we come back here, we can update, and oh, look at that. The data is now reflecting that. But I'm going to change this back. So again, my data here is linked to where I want it to be, so I can select the graph I want and update it. And now I've got the thing that I like. I've got the good stuff here. So I'm not going to go through and help you make a table from this 12 because that's doing literally half of the skills that this is asking for you to do. But what I can show you is, again, I can remind you of this document, how to make a good data table. And what I will do is I'll walk you through what I did here to recreate something that looks somewhat similar to this table that we see here, because this is a very organized table here. It looks nice. It includes all data, both my raw and my processed here, right? I've got a space for trial numbers, for trial recordings, as well as average here. I've got all of my manipulations. I've got specifically what is my independent variable, what is my dependent variable, what am I measuring my dependent variable in. So I can walk you through what I did to get there. In this case, what I did is I created a 5x6 table. 1, 2, 3, yep, a 5x6 table. So I'm going to, in my Google Doc, insert a table that is 1, 2, 3, 4, 5 by 2, 3, 4, 5, 6. And here's where it gets really, really neat, really cool. What we can do is we can select 2 cells of this table. If you right click it, you'll see this option to merge them. And now this is one large cell. And so this is where I can put what is my plane design. Now, of course, this was already probably defined. What is plane A versus B versus C versus D? This was defined earlier. I'm sure it would be. but I can put that here, and so now all of this column is for what are my planes. Oh, wrong one. I can do a similar thing across horizontally, so instead of having 3 cells across the top here, I'm just going to select all of them. I'm going to merge them, and now I can type in one single large cell. What is my distance traveled? In this case, I want inches. And here's where I can put, I had trial 1 versus trial 2 versus trial 3. And one more time, I can merge these ones to make one large cell. And here's where I'll say this is going to be the mean. This is going to be this process data, average distance, traveled in inches. Again, I want my units. Now, this is personal preference now, but I much prefer when my tables are center aligned rather than left or right aligned. It's just personal preference. You can do whatever you like. This is just easier in my eyes. It feels more symmetrical is all. Here's where I can input my data now. All that good stuff. Cool. Oh, that's supposed to be down here. Three, 296, 123, 15, 281, 232, 166. Oh, that's 281, 232, 166, 106. Which goes against making process graphs. I will address this right now because this is currently related to what we're talking about. So AJ asks, do you have an organized, properly labeled raw data table in the 7 to 8 category, which goes against the statement of making process graph? This table is different than this graph. This is a table that contains all of my raw data. Additionally, it also contains my process data. And this is a graph that only shows my process data. Now, the other thing that this also talks about in the rubric, where is it? Here we go, process data. Did you perform and show some sort of calculation to summarize your data? What I will say is, I think most people who would be reading scientific papers, i.e. anyone who's in high school or above, is familiar with the process to calculate an average, to calculate a mean. So I'm not going to stress about it here. You might have heard most of the time if you're writing papers in any sort of way that if it's easily understood or well understood by the general public or well known by the general public, you don't have to cite it or whatever. It's a very similar thing here. Most people know what calculations it takes to calculate the mean. But if you want to practice a good skill of including that calculation, you can say in some sort of, I might title this Figure 1. And Figure 1 contains raw data directly from flight testing experiments. Also contains process data in the form of an average of the 3 trials. This was calculated by, and then you might be able to type out, I've seen some people actually type out the equation. You could just say this was calculated by adding all of the data from the trials and then dividing by the number of trials, right? That's just what an average is. Add all the options, divide by whatever that is. N1 plus N2 plus N3 ... all over N, whatever N ends up being. And realistically, that's all the things that I really feel like I need to cover here. Everything else that we care about now in Criterion C, basically all of this, this is all stuff from you. You are now to take, whenever you take these data, whenever you take this data set and you create your tables and your graphs, you are now to be the Lorax of science and talk for the numbers. What are the numbers telling you? What trends do you see in the numbers? Are there any outliers? Are there any things that jump out at you as interesting that you can talk about? Can you explain why, right? What scientific knowledge do we have regarding cellular transport that we can help to use to explain whatever trends you might be seeing either in the numbers or in the graphs, whatever that is? Again, I just want to reiterate that when you make your claim, when you go back to your hypothesis, whatever the hypothesis is, do you support it or do you refute it? We are not proving, or we don't prove anything, whether we prove true or prove false. We only support or refute it, right? We can support it or reject it. So do we support or reject our original hypothesis, our original answer to this question? What numbers help you make that claim, and why do those numbers help you make your claim? What is the science that those numbers tell you that refer back to the context, in this case temperature and diffusion? So that's about where I'm going to end it here for the larger stuff. If you have some other questions, which I have a couple more that I still need to address, you can stay and get those answered. You can ask them now if you've had them come up in your head. But if this is all you were looking for, just kind of trying to hear this one more time, then cool. Love that. Then you're good to go. Good luck studying, and good luck with this. Like I said, this hopefully shouldn't take you too much time. You should hopefully be able to knock this out, and I hope that this helped in that process. And so if you want to stay and hear the answers to the questions, you're more than welcome to now. So going back to AJ's question, again, I want to reiterate AJ's question here. AJ's question asks about the difference basically between a table and a graph. This is a table. Figure 1 here is a table that contains raw data directly obtained from the flight testing experiments. It also contains process data in the form of an average of the 3 trials. Whereas this, I would call this figure 2. Figure 2 here, no, not 2B. Whoops. Figure 2 here, this is a bar graph that visualizes or shows, what do you want to call it, the average flight distance for each of the plane designs as calculated above, whatever, it's calculated above in figure 1. You might want to reference where you for each of the plane designs. If you refer to something as figure 1 and figure 2, which is common practice as you get older, just make sure that you're referencing, that you give a figure title, you tell me what we're looking at, and then you also, if you're using information regarding something or from something, that you should refer back to it. So here I'm using numbers that I obtained in figure 1, so I'm going to make sure that I tell the reader, hey, I got these in figure 1. That the numbers that I'm graphing here are numbers that I obtained and I showed and talked about, introduced in figure 1. So this is a table of both raw data as well as process data. This is a graph. In this case, I am graphing the process data because this is a lot less visually loud than this. This is very visually loud and hard to read. into the 7.8 category. I'm not sure if you already talked about this since it's a little bit late, but it also talks about using qualitative data. Is that just the observations we made, or do we make a table for that too? Qualitative data, qualitative data are just, some of the observations that you make. So from this 10 hours worth of fizzing, what observations do you make? That can just, in a larger sense, if I were to write something bigger like the catalase lab or like the airplane design lab, I might include, just in my data collection section, whatever I title that, a place for some qualitative data as it fits, as it warrants it. But for something like we see here, where we're kind of jumping in halfway through, we're jumping in at the data analysis stage, at the data collection stage. You can, not so much a table, but you can just kind of like include that and just be like, hey, qualitative data, right? You could just something literally as simple as this, and then include it there. Would it be fine to leave a link to our data table if it is too long to fit on the document? I would encourage you to try and find a way to get the data table to fit on the document. As we get older, that's something that, if you were to print this out and submit this to something like Nature or the American Journal of Genetics, the American Medicine Journal, whatever that is, all of the data should be there somewhere in that paper itself. It's not going to be like, oh, this data, the table that includes this data can be found at this link. So I would encourage you to try and find a formatting way that you could get this in there. What we could do now is, if it might help you, you could format and page orientation and go to landscape, so it'll make the pages longer or wider instead of longer. That could work for now, but I would encourage you to stay in a portrait and see if you can get the data in here some way. That would be good. Maybe it means that you shrink this stuff down, right? Let's go to even something like size 8, and we can maybe start adding some tables in here. We can start squeezing and changing the size of different things here, so we're given more room where we need it. So you can play around with the formatting of tables here directly in Google Docs. But like I said, I'd encourage you to try and get something that looks like a traditional format portrait, a readable font size like 11 or 12, and then play around as you need it. Any other questions? Okay, if it doesn't seem like there are any other questions then, so thank you all for joining on such a short notice. I hope that this was helpful, and I hope I hope that that you can use this in the future. I will take the recording of this, and again, it's only going to record what my camera is showing, so your faces won't be in it, so don't worry about that. Granted, I don't think anyone turned their cameras on anyway, but so I'm going to try and get that uploaded to YouTube and posted to Canvas as soon as possible. We'll see how long that upload takes. So if there's nothing else, then you are good to go. So thank you. Goodbye.